Hello, and welcome back to another day of Mr. Allen's Random Videos. Today, I can't believe I forgot about something. I forgot that yesterday was the 40th anniversary of the Mount St. Helens eruption in 1980, which is the largest volcanic eruption in the United States history of being a country, at least. So, we're going to talk of volcanoes today. A couple fun facts. Olympus Mons is the largest volcano in the solar system. Olympus Mons is on Mars, and it is 100 times larger than Mauna Loa, which is Earth's largest volcano. Venus has the most volcanoes in the solar system. Most of Venus's surface is actually covered in volcanic activity or volcanic features, which is crazy. Could you imagine living there? Also, in the United States, we only have a few primary volcanoes in the Cascade Mountains, mainly, that are active. And then Hawaii is very active. There's three main ways to make a volcano. A divergent boundary, like Iceland, a convergent boundary, like Mount St. Helens, which we're going to talk about, and a hotspot, which is how the Hawaiian volcanoes and Yellowstone are all formed. So, let's talk Mount St. Helens. Okay, so let's talk the basics. Because we're only focusing on Mount St. Helens today, I'm going to focus just on Mount St. Helens. Mount St. Helens is a oceanic continental convergent boundary. Convergent means come together, divergent means pulled apart, and then transform boundaries are ones that slide past each other. But convergent boundaries are being pushed together. In this case, here's my happy accident drawing. You have the Pacific Ocean, you have the United States. The United States is a continental plate called the North American plate, and then the Pacific Ocean up here has a little plate right here that's called the Juan de Fuca plate that's pushing under the United States plate. We'll talk about why that is in a second, and it eventually causes Mount St. Helens. Mount St. Helens is part of a trifecta of volcanoes in that area that are created in the same way. Mount Rainier is the other, or one of the others, and Mount Hood is the third. Specifically in the case of Mount St. Helens, you have something that would look like this. You have the ocean floor, which is made of a very dense rock called basalt. You have the continental plate, North American plate, which is made of granite, which is a less dense rock. So, when you think density, you have more dense things falling under less dense things. That happens right here at the subduction zone. So, that basalt, that ocean floor, gets pushed back into the Earth's mantle, which is really hot. It melts the basalt. Well, hot things then rise. So the melted basalt then becomes magma, and it rises up, and it creates a volcano. How cool. Notice I have my happy accidents on. So, Mount St. Helens is called a stratovolcano, or a composite volcano. They can be temperamental. Sometimes they can flow quite gently, but most of the time they live dormant, like sleeping giants that are ready to explode whenever the gas builds up. Volcanoes are necessary for the Earth because they release pressure when the Earth has too much pressure being pushed into the Earth's mantle. It can be a release or a pressure release for the Earth. So, Mount St. Helens got to a point where this subduction zone built up enough pressure under the Earth, or under the volcano itself, Mount St. Helens itself, in the magma chamber, and it exploded like craziness. Mount St. Helens was actually well predicted because on the morning of May 18th, 1980, there was a 4.3 earthquake that kind of triggered it all. And earthquake activity had been increasing for days, and then all of a sudden, it just let loose and exploded. In 1980, when Mount St. Helens erupted, it killed 57 people. 200 homes were destroyed, many animals were killed and their habitats destroyed, and more than 185 miles of roads and 15 miles of railroads were damaged. It actually exploded so much that it damaged the overall shape of the Mount St. Helens mountain itself. This picture on the left is a before, that is an after the 1980 eruption. How crazy. It erupted so violently that it literally blew its own self up. So in the past 500 years, scientists have expected that Mount St. Helens has had somewhere in the range of 4 major explosive eruptions. But It did have minor volcanic activity from 2004 to 2008 when magma was kind of rising, bubbling inside of the crater itself, but then a new lava dome, that's the cap on the volcano itself, capped off in 2008 and has no longer presented any threat since. So of course, if I'm going to do something about Mount St. Helens, I might as well do a lab about it. So I got vinegar in the bottom of the bottle. I got baking soda wrapped up in this paper towel. So I'm going to push the baking soda into the bottle. I'm going to cork it off real tight as best I can. Give it a little shake to increase a reaction. And as you can see, gas is building up inside of our makeshift volcano like Mount St. Helens. And whoa! Just like Mount St. Helens, it explodes. I gotta go find that cork. Well, and there it is. Another day of Mr. Allen's random videos. Mount St. Helens. Just proof that as much as we think we know about the Earth, and as much as we think we have control over the Earth is actually in control of us, and we should respect it. Well, stay healthy, stay awesome, and we'll see you tomorrow.